Hello, welcome back to the lecture of Python. Today we will be continuing the last topic where we have left. Let's say the last topic which we were talking about was tuple, right? So we will be continuing from the tuple. Now once I'm saying that we are going to talk about tuple, as you guys know that we have already seen how we can declare tuple within the parenthesis, how we can let's say perform indexing in the tuple, all of these things, and then we have also seen the definition related to the tuple. As I remember, I haven't given any sort of question to you guys as the homework, so we'll be continuing this with this tuple series. Okay, so what I told you that tuple follows indexing, so we will first finish all the methods related to the tuple, and then we will do the bifurcation and solve the most important question related to the interview perspective, that is what is the difference between list and tuple. Okay, coming back to the point, as you guys know that list follows indexing. Okay, and I also told you that there is one more data type which follows indexing, which is your tuple. Understand one thing, that it is not necessary that every data type coming under non-primitive section follows indexing. Okay, as of now we have seen these two data types, and these two data types as of now follows indexing. Okay, so what is indexing? If you guys remember, indexing is nothing but it helps us to extract the element out of the list or the tuple based on their index position. Indexing are of two types. Let's say forward indexing, which starts from 0 and goes in the direction from left to right in the +1 manner. We have another type of indexing called as backward indexing, which goes completely opposite to that of the forward. Let's say from left to right. Let me write it down. It is from left to my bad. It is from left to right, and this goes from right to left. Your forward indexing always starts from 0, your backward indexing always starts from 1. Related to this indexing topic, we have one more topic called as slicing. Since I am saying these two topics are correlated to each other, you have to understand one thing, that the data types which supports indexing, those data types also supports slicing. Okay, so we have to understand this in that particular manner. Now what is slicing? First we have to understand that indexing was helping us to extract single element at a time. Extract one element at a time out of the list or tuple, whatever data type supports indexing. Now, when we are talking about slicing, slicing helps us to extract multiple elements at a time. Okay, so for the extraction of one element at a time, we choose indexing. For the extraction of multiple elements at a time, we choose slicing. Also, the data type which follows indexing, those data types also follows slicing. This is the basic funda, and this is how it goes. The data type which follows indexing, those data type also follows slicing. Okay, now as of now we know that we are having two data types. First one is the list, second one is tuple, and they both follow indexing, which means they both are going to follow slicing as well. Suppose I am declaring one list here right in front of you for the example how slicing works. Okay, this is your list. Now this is the tuple: 10, 20, 22, 44, 60. Okay, previous one was the list, this one is the tuple. Now let me mark the indexes over this list or tuple. Let's say this is 0 index position, 1, 2 and 3. This is list. Now for the tuple, this is 0 index position, 1 index position, second, third and fourth. Okay, now slicing says that I can extract one element, more than one element at a time. Let's perform indexing first. Suppose if I am going to perform indexing on the list, and I want to extract this element out of the list, what I can simply write? List with, within square bracket, index position 1. That is going to give me the output as 20. Easy, right? Now, since we are going to perform slicing, what slicing says? Slicing says that I can extract more than one element at a time. For example, either from a list or a tuple, you want to extract more than one element at a time. Let's say I want to extract these three elements from the list or a tuple. As you can see, it is following some range. We are having some starting index position range and we are having some ending index position range. Okay, so if we look into the slicing, first we have to mention the name of the variable through which we want to perform slicing of. Okay, so as of now I can see I want to perform slicing of tuple. I am writing down the name of the tuple. Job done. What is the next thing? Understand the syntax of the slicing. How we can perform slicing? What is the syntax of the slicing? What is the syntax? Basically, syntax is nothing but the set of rules that helps us to write the Python program in a specific manner. You know that Python programming follows some specific rules for the program to be written, right? We cannot write the program in any manner normally. Okay, we should follow some set of rules. Now syntax is something which is going to give me those set of rules. Okay, now the syntax for slicing, it is first you have to give the name of the variable, whatever variable name you are having. Once you are done giving the name of the variable, then the next thing you have to mention the start index position. Okay, once you are done mentioning the start index position, next you have to mention the ending index position. Guys, because you know that we are extracting elements more than one at a time, so we have to give the starting index and the ending index both. Okay, now there is one third factor as well called as jumps. Okay, starting index, ending index, and the number of jumps. As of now, I am asking you to ignore this number of jumps, okay, because we will acknowledge this later. As of now, let's stick to these 2 points, which is starting index position and the ending index position. Coming back to this thing where we were performing slicing to extract these 3 elements out of the tuple. How we can do that? The question arises. So let's follow this syntax pattern. Simply, I have to first give the name of the variable. I am giving it here. What is the next step? The next step says within the square bracket, you have to mention the start index position, right? So I am mentioning the starting index position here as 1. Okay, mentioning it down here. Now focus very carefully. You can see we are having one colon. We are putting one colon there. Now we are having end index position. What is going to be the end index position if I want to extract 44? Okay, for us it is 3, but for Python we have to always pick last but one index position, so that if I'm going to write 4 here in the ending index position, it is going to pick the element still 3. So it is not rule of me, it is not rule of, let's say, some person, it is rule of Python itself, where it gives you the chance to mention the starting index position as it is. Now you have to mention the ending index position, which is 3. Okay, but we are not mentioning that. We also say another term that it is exclusive in nature. Exclusive means we have to always pick last but one. Okay, which means if we are having 3, then we have to pick till 4, then only it is going to extract the element within this particular range. So every time you are performing slicing, in the end index position section, you have to pick up the index position in the +1 manner. Okay, so you can also mention end index position +1 every time. Always understand that we are performing slicing as of now in the forward direction. Once the time will come, we will perform that in the backward direction as well. Okay, so 1:4, starting index position is 20. ending index position is 4, but it is going to pick till 3. So with that will extract 20, 22 and 44 for me. Okay, now this is the theoretical part. Let's hop into the Jupyter notebook and let's try to apply the practical application of this procedure. Okay, going back to the Jupyter notebook, I am declaring one fresh tuple. Always understand this thing that you can perform slicing on all those data types which supports indexing. Okay, don't think that we can apply slicing only for tuple, we can apply slicing only for list. No, it is applicable for both of the data types. Okay, now I'm declaring one normal tuple. This tuple contains random set of elements. Also guys, let me show you one trick. Let's say I am not mentioning the bracket as of now. Tuple apple. No, this is a string data type. We have to mention them inside the double inverted. Now we are having tuple, but see what happened. I have given here the collection of different elements or objects, but you can see I forgot to mention the brackets. So in this case, what is the issue going to happen? If I'm going to print the tuple, you must be thinking that it is going to show the error, right? If I'm going to run it, you will see it is not showing the error, but by default it is considering those collection of elements as tuple. So there is one more thing, that whenever you are declaring any non-primitive data type but you forgot to mention the bracket, Python by default picks up that variable or those set of objects as tuple by default. Why? The question arises why. Python could also consider this as list, but why it is considering that as tuple? Just keep this question in your head, because by the end of this session I am going to answer your question related to this tuple. Coming back to the topic where we were talking about the slicing, right? So once this is your tuple, I want to extract these three elements, the highlighted elements, 40, 56 and 89. Now since you can see these three highlighted elements, I want to extract. There is one more thing that we have to mention, or let's say we have to extract their index position first. Okay, so to extract their index position, we have to identify their index position. Let's count it, and right now we are working in the forward direction. This is 0, this is 1, this is 2, 3, 4, 5 and 6. We want to extract these three, which means my starting index position is going to be 2, right? So I'm just simply mentioning tuple underscore 3 within the starting index position. What is my starting index position? 2, right? Now what is my ending index position? 3, 4. Shall I mention 4? No, we have to mention 4 plus 1 every time in the ending index position. So what is 4 plus 1? 5. If you are going to mention 5, then only Python will understand that 5 is exclusive in nature. I have to pick 5 but 1 index position, which means I have to go till 4th index position. Okay, I'm running this. You see, we are capable of extracting these three elements out of the tuple. Okay, now let me give you one more example. Suppose I want to extract these three elements out of the tuple, which means 10, 203 and 40. Now in this case, what is going to happen? You have to keep one thing in mind, that we are starting from the start. So you can simply write tuple underscore 3, no problem. Within this square brackets, we know that always the starting index position of a tuple in the forward direction is nothing but 0. Okay, moving in the next part, we have to give the colon. Then you have to mention the end index position. What is the end index position? 0, 1, 2, 3. We have to go till 3, then only it is going to pick up till 4. Sorry, 2. okay, because you know that the last index position is exclusive in nature. Whatever you're going to mention in the last index position, Python is going to pick last but one element of that index. Okay, running it, you can see it is extracting 20, 203, 40 for us. Now one more thing, you can simply write tuple underscore 3 and colon 3. Okay, because if something is starting from very start, which means what, you don't need to mention. Python will by default understand if you're not mentioning anything, which means the starting index position is nothing but 0. Okay, so for us we are considering, not considering, which is true as well, if you don't want to mention something here, it will by default pick up the starting index position as 0 and will give you the same answer. So either you mention 0 or you keep this position blank. So whenever you are starting from very start, from the tuple, you don't need to mention that index position. Python will by default understand that you are starting from 0. But let's say if you are starting from somewhere else in the middle of the tuple, then you have to definitely mention the index position of that starting point. Okay. Now the third example, where I want to extract these three elements, 89, tuple and apple. In that case, again I am going to count the index position. This is 0, 1, 2, 3, 4, right? So I am going to simply mention tuple underscore 3. 4 is my index position. 5, 6. Now we are going till 6, but I told you whenever this is the ending index position, you have to always mention the answer in the +1 format. So it is written here as 6, but I am not going to paste that 6 here. I am going to write 6 plus 1, that is going to be 7. Okay, running it, you can see 89, tuple and apple is getting extracted. Similarly, the case where we were not writing anything when we were starting from the end of the tuple, the same way, if you are going till the end of the tuple, you don't need to mention the ending index position as well. Let's say 4 colon, leave it. Why? Because Python will by default understand that it has to go till the end of the tuple or a list. Okay, so since whenever you don't want to mention the zeroed index position, you can leave the position blank. Python will by default understand that it should start from the very start. Whenever you want to keep the end index position till the end of the tuple, you can give the end index position +1, which is 7 in this case, or you can also leave this position as blank, because Python again is going to understand that if you are not mentioning anything in the end index position, which means you have to go till the end of the list. Okay, so it is going to give you the same answer again. Okay, this is all about your slicing. You can now perform the same thing of slicing with the list as well. Look into this thing and focus that we are performing slicing in the forward direction. Now we will see how we can perform slicing in the backward direction. Okay, let me erase some of the things from the whiteboard to make the space for us. Let's remove this. Now we are going to perform the slicing in the reverse manner. Why? What is the reason? Okay, let me show you the reason that why are we doing the backward slicing. First of all, for our ease, right? When I'm saying ease, which means, let's say if you want to extract the elements where the tuple is very huge and you want to extract the elements from the last. So in that case, you won't be sitting there and manually counting their index position. You can go in the backward direction as well, right? So let's say I'm going to erase this list. I'm going to declare one new list. Okay, now we are going to perform backward indexing in the list, or sorry, backward slicing I'm talking about. Okay, now the slicing to be forward, okay, we have seen the example, very easy. Now we are going to talk about backward slicing. Backward slicing means what? Let's say we are having a tuple or a list. Whatever you want, you can choose. There is no restriction. This is your tuple. Let's say 20, 30, 40, 50, 60, X, Y, Z. Okay. Now these are the element present inside the tuple. What is the next thing? The next thing is that we have to extract, okay, this XYZ out of this tuple. Okay. Now we are taking the help of backward slicing for that. If we want to extract the single element, then we are going to take the help of backward indexing. But as I can see, I have to extract multiple elements. I'm going to take the help of backward slicing. Okay. Since this is the backward slicing, let me show you one more thing. Backward slicing says that the syntax is not going to change. Okay. You have to again mention the start index position, colon the end index position, and the number of jumps. Okay. Now wait for a minute. This equals to is not required. You have to mention the name of the list or the tuple first. Okay. So the number of jumps I am ignoring as of now. We will see that part later. Let's stick to this starting and ending index position. Always remember this ending index position is all going to be written in the +1 manner. Okay. Now you also understand how my backward indexing is going to be written. This is -1, this is -2, this is -3, this is -4, -5, -6, -7 and -8. Okay, these are the indexes of the element present inside the tuple. I want to extract this XYZ. Okay, so when you want to extract this XYZ, you are going to simply write tuple underscore 1, no problem. Within the square bracket, you are going to write the starting index position. What is the starting index position? -3. Colon. What is the ending index position? -1. But we have to go in the +1 manner, right? If I am going to go in the +1 manner, what should I write? Nothing. Okay, leave it as it is, because Python will understand if you are moving in this direction. If you are mentioning -3 as the start index position, by default you are going till the end of the list if you are not mentioning anything here. That's what we have seen in the example as of now. Leave it. Okay, understand that we are moving in this direction. X, Y, Z is going to get printed. Getting the point? Making sense? Let's go back to this tuple. Now we are going to extract this 89 tuple and apple with the help of backward indexing. Okay, this is going to be -1, -2, -3. I'm simply writing tuple underscore 3, -3 as my index position, and leaving the ending index position as blank, because if you are moving from left to right, by default I don't need to mention the ending index position, because Python will go till the end of the list or tuple. You can see 89 tuple apple. So you can see we have multiple ways of extracting the combination of elements out of the tuple. Either you can write 4:7, either you can write 4 colon and leave it, either you can also write -3 colon and leave it. Okay, so this is how you can extract with the help of backward indexing. Now backward indexing, when moving in this direction, we are performing the things like this. Okay, what if we want to reverse the positioning of XYZ? Getting it? Let me erase, let me clean the drawings. Let's pick up few more examples. Okay, let's pick up few more examples and then we'll move forward. Oh, my bad. Give me a moment. Okay, keeping the index positions intact. No problem. Coming back to the point, let's say I want to extract these 3 out of this tuple with the help of backward indexing. What I'm going to do, I'm going to write the name of the tuple as it is, tuple underscore 1. What is the starting index position? -6, right? Mentioning -6. Because we have to extract 40, 50 and 60, right? What is going to be my ending index position? -4. But ending index position is always exclusive in nature. You have to go one more step to pick that ending index position. Simple. Okay? -6 colon -3. That is going to extract 40, 50, 60 for you. Let's do one more example. We have to extract this thing. 20, 40, 50, 60. What we are going to do? We are going to mention the name of the tuple first. Starting index position is -7. No problem. We have to write the starting index position as it is. Now, what is the ending index position? Written here as -4. We have to always pick last but 1, which means -4 is there. We have to go up till -3. Then only it is going to pick up the elements starting from -7 till -4. If you are going to mention -3, then only it will come till here and pick up the elements. So this is, you can consider the anomaly of the Python or the built-in of the Python. Let's say it is built in this particular manner and we don't have any option to deal with such kind of activity. Okay. So this is the slicing related to the tuple. Now coming back to the point, let's pick up this tuple once again for your reference here, and I'm trying to extract, let's say 56, 89 and tuple with the help of backward indexing. This is going to be a -1, -2, -3, -4. Okay, so I'm writing tuple underscore 3. -4 is my starting index position. Since we are extracting -4, -1, -2, -3, -4, we have to extract these 3, which means we have to go till -1. Okay, tuple carries -2 as its index position. We have to add one more entry, then only Python is going to pick up till the tuple. Running it, you can see 56, 89 and tuple. Now you are master of the slicing. You have done the forward slicing, you have also done the backward slicing. Okay, coming back to the point, I have given you, we are jumping into the next topic related to the tuple. Okay, what is the next topic? The next topic is called as nested tuple. When I'm saying nested tuple, which means tuple inside the tuple. Okay, simply writing it down, tuple underscore 1, declaring the values 10, 20, 30, 60, like this. Now in one element space, I'm again declaring one tuple. Okay, once done declaring the tuple, now it is not necessary, guys, you can declare whatever type of values you want inside the tuple. I have declared such kind of values. So this is tuple inside the tuple. I'm picking this up. Let's give it a look on the visual tutor. Okay, my bad. Pasting it down, visualizing the execution, you will see the same way. You have seen the same thing happening with the list as well. Okay, even if you want to perform the indexing, let's say if you want to extract 5, 6, 8, 6, you have to first write 8 in the square bracket, and in another square bracket you have to mention 1. That's how you can extract 5, 6, 8, 6. Okay, going back, now we will see what all methods are available associated with the tuple. Okay, how we can do that? If you guys remember, we have one built-in function called as help, and in the help I am going to write tuple. So help of tuple will give me all the methods. You can see it is giving me help on class tuple. Now it is also giving you the definition. As of now, ignore it. Once we'll have a discussion over it, then you can look into it. Now scrolling it down, you can see I already told you that there is one listing of methods which are defined. Okay, so these are the listing of methods, and all the methods which are starting from the double underscore, we have to ignore them. Okay, ignoring these methods, scrolling it down, you can see we only have two methods available for the tuple. If you guys remember, but in the case of the list, there were so many methods available for the list. But here in the case of tuple, it is very few and limited. Okay, from this point, the difference between list and tuple is going to get created. Okay, what is the exact difference between list and tuple, we are going to understand from this point. But first of all, let's cover this count and index, how this works. Let's say this is the tuple which we have already created. I want to count the occurrence of 90 in this tuple. How many times 90 appeared in the tuple underscore 1? Let me write it down. How many times 90 appeared in the tuple underscore 1? So do you understand one thing? It is helping us to count the number of occurrence of 90. Okay, how we can do that? Simply mention the name of the tuple from which we want to perform the counting. For us, in our case, it is tuple underscore 1. Simply writing dot count. After writing dot count, within the bracket, I have to mention of which element I want to get the count of. I want to get the count of 90. I'm running it. Okay, tuple underscore 1 was not defined. We have to run this cell. After running this cell, coming back to the point, it is working. That is giving me the count as 2. If you want to cross verify, you can simply print the tuple underscore 1 and check how many 90s are there. If the 90 is present inside this tuple, guys, remember that it is not going to count that 90, because this whole tuple is acting as an element, right? So this element is one separate tuple, and we cannot say that I'm going to peep inside that tuple and count 90. No, it is not possible. Okay, now 90, if it is present here normally like any other element present here, so as I can see 90, two 90s are there, that's why it is counting the 90 as count 2. Now suppose if you want to identify the index position of 60, we have done the same thing in the list as well. How to identify the index position of an element. Okay, suppose if I want to find the index position of 60, then how it is going to work? You need to simply mention tuple underscore 1 dot index, and then you need to mention the element as 60. You can see it is giving me the index position as 3. Now suppose 90 is appearing twice, right? And if I want to know the index position of 90, the question arises which 90 it is going to pick while giving me the index position. So it is always going to pick up the first occurrence. So tuple dot index, mentioning the 90, running it. So from this place, it is going to mention the index position as 6. Okay, because it is counting the index position of the first occurrence. Okay, if it is going to count the index position of the next occurrence, no, first occurrence. Whenever the first appearance of the 90 is going to look like, is going to count that value only. Okay, fine, let's move forward. Here we completed all the methods related to the tuple. Now the next part is, what is the actual difference between list and tuple? It is the only difference of bracket, or do we have some major differences between them? Okay, now look into this thing very carefully. Let me erase this thing, and let's talk about difference between list and tuple. Very important topic, very important from interview perspective as well. Okay, Suppose I am declaring one list here. 20, 30, 40, 50, 80, like this. Now I want to replace this 40 with 400. Is it possible in a list? Yes, of course it is. You can simply mention the name of the list, its index position. What is the index position of 40? 0, 1, 2, right? 2 is the index position of 40. Putting 1 equals to here and simply writing 400. Okay, so the second index position, I am replacing that second index position with the new value, which is 400. Now your modified list is going to look like this: 20, 30, 400, 50 and 80. Simple, very simple. Okay, so 400 is going to appear. We can replace the element present inside the list. Now let's choose tuple. I am declaring one tuple here: 20, 30, 40, 50, 80. Same set of elements are there. Now I want to replace this 40 with 400. Okay, what I will do, I am going to write the same thing. The thing which we have done for the tuple, for the list, I am going to do the same thing for the tuple. Mentioning the second index position and writing 400. Okay, now we will perform this same activity in the Jupyter notebook and see if both of these things are possible. Okay, declaring list of check here as 10, 20, 30, 40, like this. Tuple of check here 10, 20, 30, 40, 50. Now I am going to replace 40 with 400 for list of check. Okay, simply writing list of check within the bracket. What is the index position of 40? 0, 1, 2, 3, or you can write -2 as well, is equals to 400. Printing the list of check. Successfully working. Now my list is updated. I replaced one element present inside the list. Now hopping into the different tuple. Tuple of check with the third index position, I want to make it 400. What it is doing? It is giving me the error. Tuple objects does not support item assignment. Which means what? Once created, we cannot edit the tuple. Make sense? Tuples are uneditable. Once we create tuple, we cannot change them. It is not allowed to change a tuple once created. You cannot even change the tuple. You cannot even change the elements present inside the tuple. Make sense? Going back to the point, this thing is not possible. This thing is. Okay, so whenever we define something, predefined thing, and we edit it or manipulate it, if addition is possible, we call them as mutable data type. If addition, let's say if I want to not addition, if editing is not possible, then I am going to call this as immutable. So when something is mutable, where the editing is allowed, I can replace the elements, I can add the elements, I can remove the elements. When something is not editing, they are immutable, which means the editing is not allowed. The predefined tuple is there. Even if you want to add the elements into the tuple, remove the elements from the tuple, not possible. Okay, so let's understand the major difference between the list and tuple and how you are going to answer the question. Let's say this is list, this is tuple. Okay, List we declare with the help of square brackets. First difference. Tuple we declare with the help of parenthesis. Okay, this is the first difference of tuple. Second difference is that these are mutable in nature, which means once I declare the list, I can add elements inside the list, remove elements from the list, or replace elements from the list. If you guys remember, addition and removal we have already seen with the help of built-in methods, right? And right now I have also shown you the replacement of the elements. Here in this case, when we are talking about tuple, it is immutable in nature because we don't have any sort of method that will help me to add the element in a tuple. We don't have any sort of method that will help me to remove the elements from the tuple, and neither we can replace the elements from the tuple. Not possible. Third thing, the question arises which one is supposed to be faster? Which one is going to be considered as the fastest one? List is the fastest one or the tuple is the fastest one? Okay, so let me tell you the answer. When something is mutable, which means I have to go back in the memory every time I'm going to make the changes, that is going to consume a lot of time, right? So this list is slower as compared to that of tuple because editing is allowed here. This one is faster. Why it is faster? Because it is immutable. I cannot change the values present inside the tuple. Once I cannot change something, which means I don't need to go back to the memory again and again to make the manipulations or modification. And it is going to be proof that it is comparatively faster than that of the list. Okay, here we close the topic of list and tuple along with the indexing and slicing. We are done with the two non-primitive data type, which is list and tuple. In upcoming lecture, we are going to cover another two data type, which is set and dictionary, and after that we will be starting with the conditional statement. Once your data types are done, which means you are ready to write any sort of code in Python. Okay, this is the rough idea of the difference between list and tuple. You guys can Google it or you guys can refer to my notes for this particular activity, or let's say particular difference. I have already given you the difference in my words. If you want to capture the difference in technical terms, you can go through the notes or you can search this thing on Google as well. Okay, I was just giving you the practical and basic idea related to this. Okay, so yes, please do solve your homework. I guess I have given you one homework, right? No, I haven't. Okay, so let me give you one homework. The homework says that how we can reverse a tuple. Is it possible? Okay, if it is possible, then how? If it is not possible, the answer is no. Very simple. Okay, but let me tell you beforehand that yes, it is possible. That we will see in the upcoming lecture how we can reverse a tuple, and we will continue with the set and dictionary as well. Okay, thanks for joining. And we are, let's say we covered 10% of the Python. I hope you guys are feeling confident with me. Thank you, and we'll be meeting in the next lecture.